put on. Yeah, working. Okay, so this is the first of a two-part workshop that we wanted to do about human factors and technology safety in healthcare. And we subtitled it Risk Management, the Age of AI. Today, we'll be providing more background on some human factors methods with a little bit of a informal assignment to do between now and next week. And next week, we'll get into how some of these methods are used in analyzing AI applications. But I would like to say the methods I'll talk about today can be used for analyzing many different types of health information or generally technology innovations. And I'm Andre Kushniruk, professor here at UVic, along with Elizabeth Borycki. So we'll kind of start with basics today and then build up to how these basic tools can be used for analyzing any type of advanced system. So the outline today is what is human factors and why are they critical in healthcare? There's a lot of talk about smart systems and advanced innovation, but we continually find that one of the areas that's left out is human factors. And often the discussion doesn't include what concrete methods can be used to improve usability and safety of systems. So that'll be a focus for sure. I also want to bring in the relation between usability and safety, begin to bring in it today, and talk about it next week. Was recently at an AI conference where safety was one of the biggest topics, but once again, there weren't a lot of concrete methods presented, so hopefully we can move that along. To begin with, I'll start with the very basic methods today, usability inspection, and the two methods that I've used a lot for that. And next week, we get into the more challenging stuff on how to actually test systems with live users in live clinical settings, including a range of examples. So my background is was in computer science and psychology, and I've been working in human factors for a while and the area of usability. Also, some background in cognitive science and have worked in applied AI in the past and kind of coming back to it many years later, but with a human factors lens. Also presenting today and next week will be Elizabeth Borycki, who has worked in human factors but moved into the area of technology safety, also clinical workflow and system design and implementation. So the goal today, well, is to become familiar with the basic human factors approaches or building blocks in health informatics for design and evaluation of systems and applications that are both usable and useful. You need both usability and usefulness for a system to be adopted. And the other objective is to learn specific methods for testing emerging systems for both usability and safety from a human factors perspective. So we all know about the potential of healthcare information systems to improve healthcare, and it looks like we're depending on that a lot to improve things from the current situation in healthcare. And the list there are all the different types of systems. We've worked with all of them with the methods I'll talk about today, beginning with electronic health record innovations, decision support systems. I'll talk about that next week when we have some case examples. Online clinical guidelines, a variety of educational systems in healthcare for both health professional education and lay people. Patient information systems that were designed specifically for access by patients. We've worked in the area of handheld and mobile applications and devices for a while. And of course, AI applications have come to the fore recently. And in terms of, as I said, the sub-theme will be not today, but more next week on AI applications. But we can say there's an ever-increasing range and scope of smart technologies. And having worked in the AI field many years ago, AI is not a singular technology. It's many different technologies and research areas, each with its own history, trajectory, and expectation. But the theme today is that it's really no different than any other health innovation in wanting to apply methods to improve the interaction with the user and ensure safety. So it's not a different type of thing from that perspective, and that's kind of the theme I've been trying to get across these days. And everything from intelligent databases, machine learning, deep learning systems, the term is used a lot now, predictive analytics, and the list goes on, including robotics. Won't get into in this presentation, but we recently set a lab up where we're looking now at human-robot interaction. And at the top there is a robotic therapeutic robot that we got recently called Meso. We're studying interactions with it, beginning to at this regard. And today we're also getting the robot at the bottom. His name is Pepper. It should be arriving today, apparently. So there's a whole lot of different applications, but one of the themes is that we still need to look at the human factors and safety perspective even more so. And the reason for that is if we want the technology to actually be adopted. And over the years, I've worked in many areas of health IP, and there's often the new technology comes out and there's high expectations. But you get reports in the literature and the trade journals about, these were two examples. One is about electronic health record frustrations and the lack of what's known as user-centered design, leading to very unusable systems, as some of you clinicians are probably still struggling with. A lot of that has to do with not well-designed human factors. And the same applies for technologies in areas like AI and cardiology and image processing. Often the hardest part is how to integrate that into clinical practice in a way that actually works for the end users. And again, that is a human factors issue. And just one slide here on Gartner's hype cycle. I've always liked Gartner's hype cycle. This one is the hype cycle for AI 2019. And it really applies to any technology that comes in. There's an innovation trigger on the left-hand side, and a lot of expectations come up. And Gartner describes that as a peak of inflated expectations. And we can locate any number of, as I mentioned, AI and other technologies of many types. Chatbots might be located in 2019 at the top of expectations. And usually what happens is technology doesn't deliver exactly what people thought it would, and it falls down into the trough of disillusionment. And hopefully the technology, if it's useful, becomes more practical and eventually moves up the slope of enlightenment to the plateau of productivity. So our goal in bringing human factors to new technology is to try to get good products into the plateau of productivity. And this curve is very similar for many types of innovations. So why do we need to consider human factors in the age of AI? Well, a significant number of health information systems do not get adopted or do not meet expectations. And having worked in AI through several cycles of it, I mean, I worked in the 80s, and we had something called an AI winter by 1990. There was so much expectation that didn't live up to it. And then it kind of went underground for a while. And now with success of generative AI, it's coming back, but I'm sure we'll still end up seeing that cycle. How do we integrate it into workflow activities, people's lives? Even technically sound systems may end up not getting used by users. And we need to have a scientific way to understand why to develop more acceptable systems. And from our perspective, this is a need for increased consideration of human factors. Whoops. So issues with healthcare IP innovation, I will speak more broadly, challenges of implementing information systems in healthcare. I've mentioned acceptance, usability and user experience. I'll talk a bit more about user experience next week. We'll begin to talk about reduction of errors. We want systems to reduce errors, not accidentally increase the error rate or introduce new errors. And this is a very difficult topic, and we need better methods for analyzing this. We want user satisfaction, and we also want to be able to, as I said, integration of technology into people's work activities. The term workflow is very important. So we could argue that issues related to human-computer interaction, or HCI for short, may be the single most important barrier to successful implementation of systems, not just in healthcare, but many other domains. So the problem is adoption issues. Implementations may fail due to end-user issues or not be implemented. Reports of new technologies that are hard to use or potentially unsafe, which is critical in healthcare. We can't have unsafe systems. And many reports of increased workload of healthcare workers rather than decreasing it. And this I've heard also from many new AI applications, having talked to people working in imaging and radiology and other areas. So this hasn't gone away with new technology. So the solution is applying concepts from human factors and usability engineering into system design, implementation, purchasing, procurement. We push that angle in some other countries to get them to use some of the methods I'll talk about today when they're actually deciding on what systems to select for a reason, whether it's electronic health record, decision support systems, or AI systems. It's still the same. And as applied research for conducting the areas of user adoption, impact of technology, usability, and error. So the methods I'll talk about today have a double edge. They can be used for research projects, for masters or PhDs, but they also have and can be used practically in hospitals, for implementers and designers and companies. And the methods have been used for all of those. So today I want to introduce what I call low-cost usability engineering methods and prove that this doesn't require an expensive lab, and give some examples, and we'll move it along next week as well. So I always like to begin with what is human factors. I look at a very encompassing definition that it's a scientific discipline concerned with the understanding of interactions among humans and other elements of a system. And note that system can be very broad. It can be another technology, a computer, software, another person, multiple people, team, or even an organization. So this is a very holistic definition of human factors. And also the profession that applies theory, principles, and methods in order to optimize human well-being. So let's bring a little bit back to one of our sub-themes, which we'll get into more next week. But in relation to AI, with all the AI IP innovations in healthcare, human factors have still come to the fore. These are issues you can consider under that broad definition of human factors, issues of user trust, how best to integrate technology into existing workflows, what part of the activity in healthcare should be done by a human, what part by a computer. This is often an area that is not even analyzed properly, if at all. Safety issues for ensuring user interaction with the system don't inadvertently lead to technology-induced error, which Elizabeth Borycki will talk about. And there's a buzzword, human-centered AI. But to actually achieve human-centered AI is going to involve a focus on how emerging systems help humans complete tasks and work activities effectively and efficiently. So again, I always like to start with the basic definitions of what we're talking about. I know the term user experience has come up. I'll also talk about that, the difference of similarity of usability next week. I have a nice slide on that, but I'd like to begin with usability. As in the past, people talked about user-friendliness, and that was rather vague. But some of the best definitions, my favorite came from Zeni Priest. It was a textbook from 2000, quite a while ago. But it was the definition of usability as a measure of ease of use of a system in terms of a number of dimensions. And this was brilliant because every dimension can become an objective of an evaluation study, but together they make up usability. So one is learnability. How easy is it to learn or not how to use a system? So we've done studies, for example, with electronic health records, looking at what the learning curve was. If they put training on it, how many weeks, a month did it take to learn all the functions or reduce the number of errors they always make when they start using a system. Again, this can apply to any type of healthcare advanced technology. Effectiveness is, does the thing do what it's supposed to? If it's supposed to give good clinical advice, does it actually do it? Thirdly is efficiency. Does the system do what it's supposed to, but does it take 10 mouse clicks when it should take 5, or could take 5? Fourthly, satisfaction, or users perceiving satisfaction with it. And last but not least, included in this definition was safety. And the definition here is similar. I'll talk about the standards, international standards definition next week, but this one is the one I actually prefer, because you can say in evaluating a system, am I going to look at which one or more of these different dimensions of usability and design very focused studies around them. And I'll talk next week a bit about user experience. The buzzword came up later on, and often the labs that do usability have been relabeled as UX or user experience labs. Very similar, kind of a broader concept though. So what approaches do we have? And in the two workshops we have, you'll see all of them and maybe try a few of them out. We'll start with the most basic, which is called usability inspection. And there's two methods there that we'll talk about today. Usability testing is more involved and usually involves video recording users doing tasks. And at the end of today, not like a big assignment, but I have, anybody who wants the slides, just email me. I'll have my email at the end. Some instructions for doing screen recording. You can screen record yourself using a technology, and that will be the input to what we're going to call usability testing, which we'll do in detail next week. And related to that, moving it along to more realistic scenarios, is what we've called clinical simulations. The usability testing is observing representative users, it could be doctors, nurses, patients, doing representative tasks with the system, looking at the patient, getting clinical advice. With simulations, we actually extend that and say representative users doing representative tasks in real or simulated settings. And finally, there's a whole other branch of usability, which I'll only touch on in these two workshops. I call usability in the labs, that relates to remote usability tracking and automated user tracking. And there's a number of different software for doing this. You can deploy, say, on a web app to see who's using it, how many people are using what functions. Although, as I will explain today, it won't replace doing the detailed level studies if we really want to know how people experience the system. And then there's also usability in the labs would include, in some countries, they sent out labs, national online usability studies, Finland, for example, about EHR usability. Won't get into that today. So usability testing, as I mentioned, we'll do next week. Can be applied throughout the system development lifecycle. And the idea is simple. You observe users doing a task with a system, a typical task. And often we have them do two things. Think aloud, this is just verbalize your thoughts, and we record what they're doing on the screen and audio. So that's just a picture of me thinking aloud. Can't hear me thinking aloud while using a personal health record in my office. And then notice we have a camera recording me from the outside, but for a lot of what you need to do, you don't even need that. There's a lot of free screen recording software, and I have all the information about that at the end of this presentation that you can try out, where you can actually collect data on yourself or anyone else using a system, and you can use that digital video data to pinpoint precisely where there's issues. So as I said, this is an area I really like. I'll get into that more next week. The objective is designing more efficient systems. We've done well over 100 projects using the method. Better fitting into workflow optimization of systems. As I said, some of the methods today can be used and have begun to be used by organizations and countries buying systems, and they have 3 or 4 different systems to select from, and you can apply the methods I'm talking about today and next week in helping to make a decision about what the best one is. So I'll just begin with the most basic, and then we'll move from there. And we'll see today how these have been expanded to methods for analyzing specific things like clinical decision support. But starting with the most simplest one, we don't actually observe the end user. Rather, we, the analysts, inspect or move through a system and examine it systematically about usability-related aspects. So it's a way of evaluating user interface designs. So the person doing this is trained. I teach a course where we train them how to do it, and after about a month, some of the students are as good as professional consultants. And the inspectors step through the system, analyzing the method very systematically. And we can have more than one. In fact, if you want into greater reliability, you get 2 or 3 or more. And the 2 methods I'll talk about. The first one is called heuristic evaluation. So I'll present the 10 that this fellow Jacob Nelson had, and I've also looked at them in light of AI, where AI is relevant to the heuristic. And I've also added that 2 at the end that I found useful that they never had. And there's a very well-known set of heuristics. You can look it up, Jacob Nelson. And the heuristic evaluation involves having a small set of evaluators examine the interface of a system and judge its compliance with recognized usability principles, otherwise known as heuristics. So the overall approach in teaching this, I have people evaluate user interfaces or interactions with systems, not just the interface. And as I mentioned, as the evaluator, you systematically progress through the interface. You should conduct this screen by screen. That's a nice objective way of going through a system. You can record and print out screens as they're going along. And as you're going along, use the analysts compare to a list of heuristics and note anything that might be, for example, a variation of a heuristic in what I call a log file. And then we can create tables or forms. I can show you an example that you can use to guide the process going through a system method systematically. For this method, and because I came from a human factors background, one of the basis of human factors work is called task analysis. And that's the idea that whenever you look at a system, to make your observations replicatable, you always have to specify what task you're dealing with. There's a method called task decomposition I won't get into, but you could, for example, break down all the tasks that you might use a help information system for and say, we'll focus on 1 or 2 specific tasks and analyze the system in relation to that task. So that way, if I find that the system's unusable for a certain task, I can compare that with someone else. Otherwise, I might be looking at the different part of the system and say it's very usable, and someone says it's not, but we looked at 2 different parts. So a task would be things like ordering a drug from a drug system or asking the system to check for drug-drug interactions. Those are all tasks. Entering patient demographic information is a task. So regardless of whether you use inspection or the video testing I'll talk about, we always discuss what task we're interested in. It could be a radiologist using an AI application to identify where a tumor might be. That would be a specific task. From Nielsen, he said, when we find the violation of the task of the heuristics that I'll go through, they have a Nielsen's rating scale, but it's not the television one. It's a rating scale for usability. So he said the numeric score of 1, if we find the problem and it's cosmetic, easy to fix, or don't bother if we don't have time. Its severity is 2 if it's a minor usability problem. And in many studies I've done, there's lots of minor usability problems, but you can't fix everything. So there's different methods for prioritizing it and saying, given time and money, we might not get to that one. 3 is a major problem, usability problem, should be given high priority. And 4th is my favorite, the usability catastrophe. Do not send the system out until you fix it. And I've seen so many systems over the years where they were deployed in real settings with usability catastrophes. which could in a normal IP system be that the system just crashes. I've seen that. And in healthcare, we once had a project with CBC on the health surveillance system. We also included a catastrophe in the health domain is when the system does something that might provide the wrong information that could be a safety issue or deadly for a patient. So I'll just mention the heuristics so we get the idea, and then we can see how we've extended them. Number one is visibility of system status, is that the user should know what state the system is in at any given moment. If they're in a process, if they're ordering something, do they know the order was complete? So it's about the idea of feedback, generic idea, but very important. It would be like showing a system status indicator at appropriate points. And I thought about this now in terms of AI. Not all applications do need to be aware of what's going on all the time, but even AI systems that run mostly autonomously will still need to let the user know if it hits, for example, a failure mode. So again, I'm looking at the original heuristics in the context of other systems as well as conventional ones, but visibility of system status, very important, common sense. Heuristic 2, matching the system, really the language in the system, to the real world. Use the natural language of the user, which presupposes knowing about who's going to use the system. And if you had an AI system, you could adapt to different types of users, but AI system or not, you don't want the terminology of the system to be beyond the user's knowledge or at too low or too high a level. And this is something we see over and over again with systems designed particularly for patients, where there was a lot of clinician input, and it often seems, no matter how much you try, it still is often too much at a medical level. I'm working on a number of projects now, and over again, the meaning of the buttons or labels on menus on the iPhone application, people didn't click on that, they didn't know what it meant. This comes up over and over again. And this whole issue of level of language terminology and the level of explanation will become even more critical with AI applications in terms of systems providing explanation of what they're doing, or chatbots. Heuristic 3 is user control and freedom. Provide clearly marked exits, allow users to redo or undo transactions, so it's harder to make irreversible actions until you commit to it. And again, putting on a lens on AI, there's a tight balance between user control versus system control with increased levels of automation. So interesting revisiting this classic heuristic in light of some newer applications. A really important one, if you do a lot of usability, you see violations all the time, is consistency and standards. Operations should be consistent within the system. You shouldn't be exiting, clicking on the right side of a window on one part of it and the left hand on the other. We've actually done studies where year, day, and month were in reverse orders in different parts of the system. And before Apple came up with the Macintosh interface, there was no standardization on if you clicked on File, Move, etc. Every application, I remember, then had a different order you had to learn. So that became what's known as a de facto standard. Web applications have a look and feel that have become known as de facto, which means that they're just taken up by industry at large. Error prevention. Systems should be easy to understand and use, harder to make errors, and when we get an error, still to this day, there are many systems that come up with unintelligible error messages. This one was way back from Apple days, but I've seen them as recently as last week where an error message is unintelligible, wouldn't know what it meant. Error 404 is meaningless. And one of the areas I worked in a very long time ago was working, my first work and computers was looking at developing intelligent help systems. That's an area where AI could help with this. But at any rate, whether the system is AI or not, you should look at it and say, does it provide error prevention information that's useful? Recognition versus recall. This heuristic is really the basis of personal computing today, because before we had icons and metaphors, like the desktop metaphor, computers were only used by computer scientists. I remember using only computer clubs. And then the Mac came out, and then iPads, everyone can use it. Why? Because it's easier for people to remember something than to recall, for example, a command line prompt, a command to enter into a prompt. So yes, today there's still a lot of command line interfaces. If you're working with Unix or system administrator, you work with command line, you memorize all the commands. But the reason why we all can use computers today, including children, was the principle of recognizing something is a lot easier than recalling it. So if you can recognize something on the screen, that makes it a lot easier. Flexibility, Nielsen 7 was flexibility and efficiency of use, that the system should accommodate different types of users. And looking at this again from this lens of AI, with the advent of AI applications, consideration of how much to automate becomes critical. And you don't want the user feeling overridden. You want them to have some flexibility as well. And systems could adapt to different levels, for example, of user literacy, but this is something we don't want to overdo flexibility. Heuristic 8 is a good one that explains why Google took off. Is aesthetic and minimalist design. Adding a lot to a screen doesn't make it better, and there's lots of reasons, from a technical one, bandwidth, although less of an issue now, but still. And we want to minimize cognitive load on the user, and people's attention span is short. So often the less you put, the better, or if you layer information. So when search engines came out, I remember there were a lot of competitors. The reason why Google won is because Google was so simple. It was the only one that had just the box in the middle of the screen, and they layered on, if you wanted, Google Scholar or other features at a secondary level. So it was the one that won, and you could argue because it had minimalist design. Heuristic 9 is helping people recover from errors. Again, we're related to the error heuristic. If you have a long form to fill out and you do something wrong, you don't want to have to search where to find it. It should locate where the error is. And again, this is somewhere where automated support for diagnosing user errors could be employed as well. This would be a no-brainer, heuristic 10, help and documentation, but I've seen many systems with no online help, or with online help that is not particularly helpful or context sensitive. So in the traditional help, you could have information organized by topics. How can I do something? And many more opportunities now with speech recognition and natural language processing and chatbots for help while using a system. Those were Nielsen's 10 heuristics. There were two that I added that I found, I think, even more useful than, or at least as useful as some of the others. One is a principle that comes from cognitive psychology called thinking. And this is, by the way, these principles are good both for evaluating systems, but also keeping in mind when they're designing a system. And thinking, the idea is people have limited short-term memory or working memory. And if you're given some new numbers or information, we can easily remember about 7 plus or minus 2. Which is why the early telephone numbers were about 7 digits. Now they add area codes, because, but that was why. So, for example, in designing a system, if you have a menu that has 100 items, by the time you scroll to the bottom, you won't remember what was at the top. Try it, so happens. So you want to chunk information in a way that's manageable for people, and that 7 plus or minus 2 numbers came from, not from computer science, but from a psychologist in the 50s who discovered that that was a number of, if you have information we haven't seen before, you would remember 7 plus or minus 2 items. So I'll just give 2 examples that came to light for me in designing systems. One was, well, I didn't design this one, I worked on evaluating it, but it was a rather confusing user interface. The menu bars had not a lot more than 7 plus or minus 2 on the left-hand side as well. and users found it difficult to locate information. I was fortunate, after working on that one, to work with this was a system that was developed from scratch in the mid-1990s at Columbia Presbyterian Hospital. And at the time we developed, well, this was the patient version of it, the interface using a whole lot of rules that we saw from Nielsen. Consistency, it was consistent with de facto web standards for how it was the first web-based BMR should look. It was supposed to a lot better than a lot of the commercial ones that were never made for the web and they put them on the web. We did it for the web from scratch. If you look on the left-hand side, there's 5 personalized items. The patient could select, for example, a data entry, data review, whatever they clicked on, another menu appeared up top with we followed all the heuristics. This was a system that did not end up requiring hardly any training or education. People learned to use it intuitively, and it actually was used in a massive hospital. It took a long time before it got turned off and they got a commercial system, which everyone then complained about because they liked this one so much. It was done using those principles. And the last one that I added as well was the inverted pyramid style of writing. That important information obviously should be at the top of the screen. And nowhere is this more important than with healthcare IP applications. Prioritization is also something that could be automated depending on impact of the information, timeliness, and prominence. So when I do a course on this, I have students assemble, go through, as I mentioned, look at a couple sample sites, could be a health website or health IP application, counting up the number of issues they found. In some cases, I have them compare 2 different products that do the same thing on the same path. So if you remember, you want to specify the path to make it reliable. And we can do all kinds of things. We can, oh yeah, this was like a work form you can use. And this was, you specify the task, for example, you're using a system to access patient case information. On the left-hand side, on the form, you can list the heuristics, and we'll talk about adding heuristics. We can add other ones specific to things like medication administration, which were developed from the literature. Elizabeth will talk about that, but this example is just using Nielsen's basic 10 and the 2 I added. And we can say, as we're going through the system, is there a violation? Comment about it, come up with its severity. Some of this is a bit subjective, but then produce a screenshot to show it. So in consulting reports I've done, the screenshots are very important because rather than just me saying there's a consistency problem on the screen, I can actually show the exact screen, circle it where the issue is located. So you can fill it out for doing a task with that system, counting up how many evaluations there are for which heuristic, commenting on it, subjectively assessing the severity, which is important when we're deciding what to attend to or not, given time and money. And I always include a particular screen to illustrate. You can do quantitative presentations of some of that qualitative data. You could have a graph. This is called the heuristic violation graph, where on the x-axis are the different heuristics, and then their frequency. And we can graph to identify immediately what areas do we need to work on. In this case, it was heuristic-free, user control and freedom. We can also, on the x-axis, put the 4 levels of problem severity: cosmetic, minor, major, and catastrophe, and graph the frequency of each of those. So as you can see, this system has 6 major problems and 4 usability catastrophes. So hopefully it's not being released before usability catastrophes. Another thing I'll mention, I didn't have in my slides, is the methods we're talking about today you don't have to wait until the system is complete before you use them. In fact, you want to build in testing during the development cycle, because in the example of catching 4 usability catastrophes, you obviously want to fix them before you release the system. So you want to build this testing in during development cycles. Results can be a graph, a report, recommendations. Reports I have students do, they come up with specific recommendations for improvement, and very similar to consulting reports if you're hired by a software company to report on what they need to fix. And the thing about this method is it's called discount usability, because as compared to what we'll talk about with user testing, this is more involved, you don't need to pay for a lot of subjects. If you're a good analyst, you could sit down and do it. However, as we'll see, no matter what you predict the users will do, you still won't know what they are until you actually observe them. So I'll hold that part till next week. Oh, I also mentioned we could compare two products on the same task. But the comparison one, the other inspection method, I'll show how these can be combined, that I've used a lot. This game is not involving observing users yet. We'll get to that later today. This one is called cognitive walkthrough. Again, you're the analyst stepping through a system. This one is useful for coming up with if there's need for optimization of number of steps or the workflow involved in doing a task. And you, as the analyst, you try to predict the user's goals, actions, and potential problems, again, in the context of a task. So I'll give an example of using a cognitive walkthrough to assess usability for a specific task, trying to anticipate user actions, problems, etc. So this was from a system that was developed. It was kind of an automated pick list for entering, well, it was electronic health record of entering patient problems from a pick list. Like if you said they have diabetes, the list was diabetes 1, 2, you select the more standard terminology on the list. In this case, it was entering patient problems, so we created a hypothetical task, entering a new patient problem, fear of traveling. We specify what the goal is. It's almost like having a log there while you're doing it and filling it in. And this can be automated to some extent. A sub-goal design, you have to decide on the operation for adding a new problem. And you notice there's an add new problem button. This part is less subjective. You can specify every action you do. So it's kind of like a user log file. You click on, you mark it down that you click on the button labeled add new problem. So we can count up number of user actions. We can also count up and indicate what the system responds to every action. A keyword search window comes up, which is called the nebula, and we're supposed to enter the text in there, and then it gives you the list of standard terms to select from. So then you come up with, is there a potential problem? User might not realize they have to enter the search term. Here's the actual screen of that system. So a bit busy looking. On the right-hand side, they've entered this med viewer on the window on the right, overlaid on top, and start entering terms like travel, and then you'll see that a number of terms appear that they're supposed to select from. So we're counting up every step. So the user has to select the term by entering the term in the search words box, and then we say what the system responds with. The system responds with a list of control terms. The user scrolls the list, and the user selects a term from the list. But early on, we found what happens if the term doesn't appear that the user wants. At any rate, we can come up with potential problems and then try it out with users. In that case, you'll probably need a special instructions box. But you see what happens. You're stepping through logging the interaction. So why is this a useful form of studying interaction? Again, it's a predictive method. You can identify potential problems and issues. You can count up for something, was it unreasonable, the number of actions or system responses, or number of user problems. So input from that has been used for optimizing interface designs on many projects, identifying potential problems, and we've also used it, recommended it used in procurement process. So if a health region is going to purchase we had some examples. I think one was video conferencing system, another one was medication administration. you can actually, if you get access to the software you might buy, which you should demand in the procurement process, you can fire the same task into the different systems and come up with a comparison of their efficiency. Remember I said efficiency was one aspect of usability. So often you'll find some extraordinary results, like one system may have taken double the number of steps to do the same task as another. So although it's a predictive method, it does provide some quantitative useful information. So if you're interested, and at the end, just email me, I'll send you the slides. A number of years back, we did a kind of combining the methods, so you don't have to do both of them separately. You basically combine them so that you do a cognitive walkthrough where you specify what task you're analyzing the system for. Every row here is a step, a goal, and then on the left-hand side, if there was a heuristic violation, you indicate that, and we can also make comments. So it really provides a lot of kind of comprehensive information. So as I said, don't worry about this one. I've got a paper on this if you're interested. Okay, so I'm gonna come back and talk about doing some how to do video recording, which will be fun to try in the next week or so if you have a few extra moments. And I will talk about a few simple things to try between now and next week. One of them I'll mention again is try out, we can do this very informally. You can pick up any health application or website, could be a health portal. Try out the idea of picking out a task that the user might do, like looking up information about a disease or a prognosis, conducting a heuristic evaluation, and trying out, does it make sense? Can you identify and record violations? And what recommendations would you make? And if you try that, we could also compare that by doing for the same task a cognitive walkthrough to see what kind of information we get from both and looking at how these two inspection methods compare. So I'll get back to that at the end where I also add the information about screen recording. But at that point, I will pause and pass it over to Elizabeth Borycki to show you how we take some of that basic stuff I've showed you and moved it up to creating heuristics related to safety of systems, including AI.
So as Andre mentioned, today's presentation is more about sort of gathering some of the background information in around usability and safety, and then how one might apply it to AI, which we'll discuss in more detail next week. It's really important that you have that background before you go ahead and start looking at technologies through a very different lens, especially specific ones such as AI. So one of the big areas of research that we have here in the School of Health Information Science is the area of looking at health technology and errors. What we found is that in the past, prior to 2004, a lot of researchers identified the many different ways that technology could be used to improve safety. But in 2004, we started to see the emergence of publications that actually demonstrated that you could have technologies inadvertently facilitate different types of errors. So the main conclusion from that research is that we have technology that can reduce medical errors as well as introduce them. And the other thing that's really interesting about this research is that there were two types of studies that took place at that time. One study demonstrated that there was a relationship between error and technologies in situ. So what happened was in that study, the errors were taking place in real world clinical environments. The other study showed that you could identify these errors in a laboratory setting. So in essence, what you could do is you could prevent them from ever occurring and migrating to that clinical setting. So what are these types of errors? We've referred to these as technology-induced errors, and they are errors that arise from the design and development of a technology, its implementation and customization for the local environment, as well as any interactions between the operation of the new technology and the new work processes that arise from its use. It also applies to technologies that are interfaced. So in healthcare, we have many technologies that exchange data and information that clinicians use across settings in order to support care processes. And they also include near misses and mistakes. And I like to think about these in terms of a near miss being something that a clinician identifies and tries to correct, and it's an opportunity to improve that technology and make it more safe. And a mistake is something that actually happens and that we need to understand the underlying reasons for why it occurred, again, so we can improve that technology and reduce the likelihood that it would cause errors in the future. And there are a lot of different types of technology-induced errors. These are just an example of some of the many types that are out there right now. And we've actually seen this in the literature over the last 20 years. So for example, a default that auto-populates with the wrong information, a display visibility problem. The clinician can't make out what actually is being said by what is being provided in terms of information by the system, and they're unable to make a decision adequately because of the fact that they can't see what's there. Navigation problems, not knowing where to find what type of information. Consistency problems, problems where the user interface indicates one thing in one part and another thing in another. And of course, we talked about earlier, Andre mentioned meaning of labels, where the clinicians and the patients don't know what the label means. In addition to that, there are issues in around how technologies support the layout and organization of information, and does it fit into workflow? We've seen as a result, some healthcare professionals have become screen-driven, and also that has affected their ability to diagnose disease as well as understand or create an idea of what's happening with the patient. In addition to this, it affects other types of things. For example, errors may also occur in terms of certain types of information being left out. So there's missing patient information. So a clinician doesn't have a fulsome idea of what's happening with the patient when making decisions. And you can also have some features and functions of specific types of user interfaces that could be associated with error. So in our work here at the School of Health Information Science in our lab, we've looked at this in terms of the continuum. So before a system's implemented, after the system's implemented, and then in a short period of time that occurs, usually 3 months, and then long term. So what happens when a system is implemented over time? And we've developed different types of approaches in order to be able to understand where the error is coming from, how it can be addressed, and then how it can be prevented. And we specifically like to deal with pruning off errors before a system's implemented. That's not to say that we don't look at errors after a system's implemented, or even while a system's been functioning for many years. The reason why you need to look at things before a system's implemented is it costs a lot less to correct an error than it does after a system's implemented. Because once it's implemented, you have to retrain your staff. You have to identify different types of processes that they need to learn. And in addition to that, you also have to address their sensitivities in and around being able to identify when the system may be causing an issue. So it's a lot less costly to be able to make those modifications before a system's implemented, when you have someone that's creating the actual technology itself in terms of its databases and its interactions and its user interface. So what is the link between usability testing and safety? We know that there is a relationship between the two. So for example, we know that specific user interface features and functions may lead to technology-induced errors, such as the one that I mentioned earlier, which is we have an auto population of a default in, let's say, a medication administration system that auto populates the field with the wrong information. So when you look at this, you start to understand that when you can conduct usability testing, it's really important to be able to look at what features and functions of that user interface lead to what types of usability issues and what types of errors that occur. And this is a really nice way of actually looking at what types of issues you have, what kinds of errors occur, and it acts as guidance for health informatics professionals to be able to start looking at what kinds of things they might modify in order to prevent errors in the future. Sorry about that, a little bit of a systems glitch on this side. We've also developed evidence-based heuristics, and these are really important because what they do is they actually allow us to also identify these particular issues before a system's been implemented. And this is some work that I did with one of my former students, Chris Carvello, on a research project many, many years ago. And it's really kind of neat because what we were able to do is we were able to identify some of the key issues as far as safety is concerned from a content, a workflow, a safeguards, and a functional perspective when you start to look at systems. And what we did is we looked at the literature and we developed as a group specific heuristics based on what the evidence was. So what evidence was there that there was a particular feature or function or particular workflow, for example, that led to a particular error. And that was derived from the literature. And as a result, we've been able to create heuristics that have been successfully used to identify potential issues. Now, when you look at those heuristics, they were originally created for a period of time when we had systems that did not necessarily involve AI. They were essentially electronic health records that were collecting data. There were decision support systems that were attached to those EHRs, and they allowed us to identify potential safety issues. But when you think about heuristics themselves also can lend themselves towards identifying potential issues. A lot of these issues are still the same. You might integrate a new technology such as an AI decision support system, and it may improve the safety of your patients. It may help you with your decision making, but you still have to consider the fact that it has to do the things that it was intended to do. So, for example, you may have a traditional decision support system that does drug-drug interaction checking. You may have something that's supported by AI that does that, but both have to produce results where you actually improve the safety of the patient and of the patient's care and address that. So it's very important from that perspective. So what are some of the kinds of things that we can look at from the perspective of AI? Well, you know, for example, AI has to be integrated into the business processes in healthcare. It should be linked to established systems that are recognized by clinicians. It should accommodate clinicians' activities and work. It should be compatible with other types of technologies that might be present in the work environment. So, for example, it should be compatible with, for example, vital signs monitors or electronic health records. It should also be compatible with other types of devices that are used. So, for example, oximeters. AI should also provide suggestions and findings, but it shouldn't impose them on the clinician. The clinicians should still use their own knowledge and judgment in terms of deciding on what to do with the patient, especially if the technology is providing information that is inconsistent with their assessments. Clinicians also need to be able to override the AI, just as they are able to override decision support systems in cases where they feel that the information that is being provided is not sufficient or is incorrect or doesn't meet the unique needs of that particular patient or situation. They also need to be able to turn off the technology if it's interfering with the care process. And that's something that's important to consider. And we also need to look at how those particular alerts, reminders, or that information that's being provided is consistent with the evidence-based research as well as organizational policies and procedures and workflows. So when you start looking at this, you need to understand that technology in of itself and in AI systems are also important in this group. You need to be tested and need to be evaluated in order for them to be able to be fully assessed and to make sure that we don't introduce new types of errors with these new types of technologies. And this is why it's really important to do work that prior to systems implementation, and that includes AI systems implementations. Now we have a little bit of homework, and I will pass this back to Andre.
Yeah, we can come back to some discussion after, but I wanted to something for next week, before next week. I've already mentioned that try out usability inspection. You could pick, it doesn't have to be EXR or working system. It could even be a web portal or website that works fine. Try out both conducting a heuristic evaluation and a cognitive walkthrough, recording evaluations and coming up with recommendations. So next week, what I want to cover is getting more into the details about how to do studies of people actually using systems. As I mentioned, this is termed not usability inspection. That was without the user. This is called usability testing. It's always involved observing users. To do this, I'm recording myself using the system as I mentioned. One of the things I have installed whenever I do this on the laptop or computer or even the mobile is software that allows me to record the screen and the audio. So that's all you need. If you were actually recording using a web-based information system, I just need to have the software installed, and I'll talk about it. It's either free or you can get it really easily on any type of system. It gets a bit more complicated if you're doing it on a mobile device, but I can talk about that next week. And you don't even really need the external camera. The only reason I do that is if I want to know what the person is doing on the desk, and then I have 2 digital videos. So I'll talk about that in detail next week, but I thought a simple thing to try before then, which will make next week hopefully very understandable, is just try recording yourself doing a task with any type of application. This will be the bread and butter data that we use for basic usability testing all the way up to advanced computer simulations. And we'll also talk about how you can take that data and we can come up with precise qualitative and quantitative analysis of where a certain number of users, like 10 or 15, are having problems with the system. So rather than predicting them, like with inspection method, we can actually collect stats on the actual interaction and user experience. So before next week, I just say try recording yourself as you use a system, use a desktop, use Excel, anything. So the first step is that you need to select the recording software. So for next week, we'll just deal with desktops or laptops. If you're using a Mac, it's really simple. I'll show in a minute. If it's on a PC, there's a lot of free software you can download, and I'll talk about that for recording screens. You may already have it. If you have to buy something, it's probably about $20, but there's free ones. I use a product called Hypercam. What used to be free, now it's $30. You can download it. It takes approximately 5 minutes to set up on your computer. You just have to say what size of the screen, part of the screen you're recording, clicking on the button saying you want the audio. And if you're using a Mac, QuickTime built in. Last time I used the Mac, it was built in. I'm also talk about how we can use Zoom. The platform, which is free, we're using right now for this presentation, can be used for collecting usability testing data, and even has the advantage. I'll get into this next week. I can conduct remote usability testing over Zoom. I can even do studies of collaborative tools involving multiple people. And as I said, the cost of this is now, for that technology, is zero. We can get it for free. The real part will be how we analyze it, which we'll get to next week too. So once you have the recording software on your laptop or desktop or whatever, and we've picked some website or application to explore, you turn the recording on. And often in doing this, I like to, you could try it yourself, and just yourself. Think aloud or verbalize what's going through your head as you're doing something, like, balancing your paycheck in Excel, or, looking up your personal information in the personal health record portal. And then when you're done doing some interaction with the system, hit stop. and you can play back probably immediately in Windows Media Player or play back in QuickTime that digital sequence of your interaction with the system. So on large-scale studies, we may do fancier things like have multiple video views and that, but this is the basic data that is really nice because you can go back and look at it many different ways, digital video. So as I mentioned, I've used on the PC, I've downloaded the software called HyperCam. It has a very simple menu for selecting on the bottom there the size of the screen we want recorded, where you want the digital file to go to. Are there any hotkeys if you want to turn it on or off? Many, many examples. And on the right-hand side was the QuickTime instructions for doing screen recording on the Mac, which was built in. And what I'll do is I will make these slides available. And at the end, I'll just have my email. I'll just email me. I can send you the slides to see what they had out there. Yesterday, I looked up what free screen recorders are available. There was a YouTube video on the 5 best free screen recorders, but there's many more. And one of the ones they listed was actually Zoom. Because, for example, right now I'm doing a presentation that will be recorded. If I was interacting with the system doing screen sharing, I could record that. So that becomes the input data for usability testing. And I'll talk about next week, but if I wanted, we were doing one project where we were usability testing with some physicians using EXR, and we were going to go to that city to do the testing. COVID came along, so instead everything was done on Zoom. We recorded on the screen, on screen sharing, what they were working, the doctor worked on the electronic record, and we even had that, they were interviewing a patient at home using Zoom. So we were able to use a free tool to actually do a sophisticated study of user interaction online during COVID. As I mentioned, QuickTime, but the simplest case is just recording yourself using it. QuickTime is built in. Windows Xbox Game Bar, it's not just for gaming. I hadn't tried that before. You go to settings, gaming, captures, but for some reason it didn't work with my version of Windows. And there's many, many more. PowerSoft Online Recorder, Flashback Express, most of these are free. OBS, Open Broadcast Studio, also has a lot of video editing features, but you don't have to do that or be that complicated. So what I'll do is my idea was basically before next week, just do nothing more than try recording yourself doing a task with task analysis idea, using an application or system, any of your choice, and then playing it back just to get an idea. And if you have what the data looks like, and you should also be able to record, like with HyperCam, there's a button for audio on, and also with QuickTime, you can select audio on. It will record what's going on the screen at the same time you're verbalizing. And this is critical because if you just record the screens, you will see what people are clicking on, but you don't know what they're thinking. If you record just the audio and not the screens, they'll say something like, well, I'm having a problem with the menu here, but you have no reference point what the menu is. So what we're really collecting is verbal and image data together that can be analyzed. So actually, I think we have lots of time for questions. Don't think we'll go a full 2 hours, but I will say just email me. I can send you that information and try it out if you have time. If you don't, doesn't matter. But you may find that very useful. A lot of people have tried it out and then were able to use that for many different types of design and evaluation studies. My email for slides or information on that in preparation for next week is simply andrek@uvic.ca. And I can send that slides and also the information about screen recording, just for you to try out, nothing more than that. So with that, I think I will end, and we've got lots of time for discussion.
I think there may be a couple questions.
Oh,
in chat.
questions in the chat, something said. Oh, stop sharing. Okay, where did that go? Oh, there it is. Oh, was I on mute the whole time? I hope not, because there was something in the chat box saying you're on mute. No?
No, we
No,
could
I
hear you.
think, yeah, I think that was just at the beginning, Andre.
Oh, okay. Actually, that came back to a teaching experience I had the first time I did that. It was before Zoom, was Blackboard Collaborate. Everyone was quiet. No one said anything for about a half hour. Okay. Oh yeah, MS Teams. Yeah, you could use MS Teams to record. Any screen recording software works. And also the nice thing about Zoom and Teams is you can, as I said, there was all this stuff about doing remote usability. All that, if I'm doing remote usability, I could be here in my office on Zoom. I give you a meeting link. You could be in Philadelphia or wherever. And then I tell you to go into the application we're testing, share your screen, and then I hit the record button while I step you through, okay, think aloud the instructions while you're using the system. And that gets recorded as a Zoom meeting. Now, actually, I've never done this till yesterday. I thought, well, yeah, I'll do that without, and I'll make a meeting, but I'll just record myself. So if you make a meeting, you can just record yourself, with screen sharing using a system, and then that just downloads to wherever you tell it. And Microsoft Teams will be the same. I think almost all the those tools for collaboration will be the same at this point. And the other ones, as I said, there's so many free ones that take about a minute to install. And QuickTime that QuickTime was working last time it was built in. Okay, Alvin, great talk, thank you. We'd love to connect with people about specific healthcare tech use case. That, Alvin, you had which use case you're thinking of, but this is a good area coming up with what use cases should we be looking at, particularly when we get to applications like AI applications. What are we testing? I don't know if we're there. And okay, no, I don't think so. So yeah, I'll just open up any thoughts, questions, or ideas. So if some of you tried this, I know I didn't get into how to record on mobile, but you can do these usability studies on a mobiles as well. Tasha, how are discussions about AI integrations on the provincial sense coming along? Are you engaged in these discussions? Well, I'm not engaged provincial, but Elizabeth and I were both engaged with a regional health authority, and they started kind of like a once-hour meeting, and must have been about 50 or more people, and issues came up because already they were saying many people in the health authority were already using ChatGPT for their work, and wanted to get a handle on. They didn't say, but I think they were trying to come up with some ultimately guidelines or recommendations on what to do with that form of AI, which has also become an issue at the university here about what we tell students. We can't use it, but then they want to use it to look something up. What is plagiarism? We have a lot of issues with that. So the health authorities definitely, but it's early on. We went to some other presentations where AI was discussed, but protocols and guidelines, from my understanding, are not really out there yet. Comment?
Yeah, I think we did recently went to a conference where a lot of the focus is on the actual AI algorithms. And it's now starting to shift. So it's changing. And from the perspective of how do you actually integrate the technology? Is it worthwhile? What use cases? Also, safety is becoming really big. Also, data, good quality data, sufficient data to be able to create data sets that you could actually train the algorithms on. and that they would function well afterwards.
And on the safety side, I don't know if Lisa's there, Lisa saw, but there was a lot of places saying we're getting into automated dictation, and to what extent that is actually accurate could lead to massive safety errors. Liam said, you mentioned how good tech is often replaced by commercial tech. Bad user experience. How to get people like us further involved so that the tech being deployed in healthcare is the best for the system, patient, and providers? That's a really good question, because a lot of the classic systems like electronic health records that were the best, the Salt Lake system in Utah, the one at Columbia, Brigham's Young, they all eventually got retired for commercial. And then people go, well, there's nothing you can do with commercial. They built it, so we can't change anything, which is not true at all. They often forget that implementation of the EHR is a long, hard process where users should be involved right from the beginning in doing it. So the user testing I'll talk about next week isn't just for the design process, which is what the standards organizations focused on for it, but it's actually totally useful when we purchase the system, because we want to get users involved. We want their feedback in designing screens, the whole process. And even if the usability testing doesn't fix everything, what we have found from experience is that when we go in as a team to do this work, word gets out that they're being listened to, and they're much more likely to adopt the system rather than feeling like the organization they're in forced it on them with the usability problems. Yeah. And Lisa said that AI systems which learn as the user interacts with them, what evaluation approaches? Well, that's a really good question. Now, the way we've been looking at the evaluation is that we're still looking at usability and safety as the two key factors. And you can, it's constantly learning, but you can stop at a certain point and do a checkpoint and say, at this point, what's its validity? And without ensuring safety, people won't want to use them. I was at a AI conference in 2018, and managers from hospitals were there, and they were saying they're reticent to use it unless it has FDA approval. And the deep learning systems, if I heard correctly at a conference recently, there were about only a few hundred that were FDA approved, 200 back in 2018, there was 50. So it's not out there yet, and people get into, is it explainable or not? But explainable or not, is it safe or not? And we're going, still have to use human factors for all of that. Because it's AI doesn't make it a different animal. Abdul, you have your hand up.
Yes, Andre, just as a thought or maybe a question, I'm not sure what it is yet. What is a clear distinctions for usability testing with the AI system compared with the classical system? What is the key differentiations?
Well, I would.
And then I've got a follow-up question after that.
We said that's similar because we say it still has to fit in workflow, it still has to be efficient. So now a lot of the systems may be less, they may be more autonomous. So some of the task is hidden from you. So again, it's still how does it fit in, and it's still ensuring safety. Is it come up with the right answer? Now, what I would say is that there were people that were working on often the typical evaluation of AI in the literature is, did it come up with the proper diagnosis of a malignant mole, 98% fine and that.
Okay.
But having worked on projects, that doesn't tell you how it would ever fit in the referral process, the whole workflow area and that. So it's like, I've worked with so many technologies, at least from my perspective, I can plug and play them. Everything in the past was advanced too, but it still didn't mean we have to do the proper due diligence on the integration issue, the safety issue. And recently, Elizabeth made a good point at our conference. If you're a doctor and you already have a method that does something and it works, why would they say, I want to replace it with something I don't know how it works and I'm not sure if it works? Kind of a,
That is I mean, that I think personally that if it doesn't work better than what you already have, what's the point?
Right.
Right? So, and
Mm.
if you consider, you're looking at things from an evidence-based point of view, if there's evidence to support one pathway and there isn't in the other case, you're going to expect the new technology to live up to the same level of evidence as the technologies you're already using. So, in order for it to convince someone that it's worthwhile to do this new thing.
But it's new, so it hasn't undergone clinical trials, which is always a thorny issue because people will say in medicine, you know, like, I want a clinical trial. If we're going to have a new splinter heart device, we have a clinical trial. But AI isn't a different animal, which creates a problem if it's new. They're not going to have that evidence.
So I think
Yeah, I
there's
mean, if it
some places that
is,
are more risk tolerant and others that aren't. And so, and I would ask you the question, if you were going to submit yourself to an intervention, would you pick one that has evidence behind it, or would you pick something that doesn't? And so that's the big
yeah,
issue here,
yeah,
is from a patient perspective. It's also the big issue from a clinician perspective, is nobody wants to harm their patients.
yeah, but but I mean, this is I understand that. I think it's been going on about interpretability of the model that you use. Is important. Therefore, in old days, we used to say that for a procedural language or other type of language, when you could trace it was traceable, then it would be fine. You can trace a program and codes and see exactly what you could actually validate your codes and very, very easily. But what I want to come back is to what I asked earlier on, that there's no this. So why can't I give the AI system the job of the usability testing itself? So because
Yeah.
I mean, if you look at the Jensen 10 commandment, I call it,
Yeah.
or plus one or two, Andre's one, we can, that easily could be incorporated within the loop of this AI systems. And also, just coming back to what Elizabeth said about interventions, is that, you see, if you would have looked at things about maybe a year or a year and a half ago, before ChatGPT, AI system was actually scary. None of the healthcare people will look at it, and so on and so forth. But if you look at it now, there are really, if you say, do you like ChatGPT, you are like, they say yes, because the response of ChatGPT is so sort of easy to understand, and they believe in it, even though it's absolutely mimicking what is out there, is not really intelligent per se, but the output is so good. So it seems to me the people now changing their mind about, even that in healthcare, maybe it's acceptable. I don't know. That's
And I would say to you, Abdul, that I would question the output. It's not referenced. We don't know what the original source is. I've done some work with it too, and it doesn't pick the best papers. so and one has to be aware of the limitations of the technology when
absolutely
considering it, right? And then even some of it looks exactly, so this format is the same, so it has the same feel and information in some cases.
But I think Mitch in a chat said something which is, it's dynamics, is learning, is continuously getting improved. So I wouldn't throw ChatGPT or Bird or the other things from the Google away from. I think I don't think it's scary. I think it's very helpful. We should learn to live with it, as a technology, rather than to dismiss it
Well, what will happen is that
in education. It seems to me in education system, what I heard is University of Aarhus says to all these students, I think Aarhus is in Denmark, isn't it? Yeah. Apparently they decided as a strategic as their strategy, every student can use ChatGPT for exam, for anything, and they evaluating it to see how things gonna go. So as just a piece of useless information for you.
One
I'll
comment.
shut up now.
I've always seen this happen. Always. And I've been through 2 or 3 cycles with AI. Is getting this hype cycle. You have that expectation, and then doesn't do what you want, and then the good technologies slowly come back on the plateau of productivity. How can we actually really integrate them? There's usually a super blast of something, and then then we start seeing the other side, underside of it, that the information may be biased or whatever. And then over time, with good technology, I'm sure ChatGPT will be integrated, but I'm seeing that same getting a cycle. It applies so well to so many technologies, and I think it will be the same here, that a lot of the good stuff will come out in the end. Yeah. So not negative, it's just that thing really does describe AI cycles very well.
I think it's a good idea to put
I got to go back to, it's a new technology. I think it's worth it to study it, find out whether it works better.
How to optimize it.
How to optimize it. But let's say if I had an existing CT scanner that can identify tumors really well, would I want to make sure that the new tech was better than that? Yes. Otherwise, it's an investment in something that might not deliver, and also might put the organization at risk for patients saying that they were using ineffectual tech.
Yeah, but I think you asked me a question about, do I trust the system or not? But I think I know there's some radiologists here, and I don't want to upset the radiologists, but some of the AI system with the radiology AI type system is far better than radiologists. I was told I have a hernia, but I didn't when I went and tested myself twice. So there you are. I mean,
Lisa, what's your take on this?
Sure. Well, two things. First, before I get to what Abdul said, as a follow-up for his first questions, that one of the differences between the AI system and the traditional information system is the type of data you're training the AI system. So you can have exactly same engine and then give it different type of data, and it comes back with different results. And we learned that for the prostate cancer diagnosis that we're using, that the original data we used was with patients with low burden disease, means that it was initial stages of the disease without expansion to liver and other places. So our software was good in picking up, but until we started using images from patients with more advanced, and it had problems with picking up the ones in liver and other things. So we have to go back and kind of augment the data we used. So that's how the major difference is.
That's a problem. That's a problem with the people who develop the model based on the wrong data set.
Well, I tell you what happens when prostate cancer imaging is just approved a few years ago. So we started imaging patients, and the first protocols were in just initial diagnosis. So the company had that kind of data. So some sort of data you develop over time. So you don't have a lot of people with advanced disease when you start. It's just FDA approved a few years ago. Is that right? So as you move forward, you kind of get to the approach. Now, to your second question, yes, there might be systems that are better than radiologists, but they don't get salaries, so we have to generate some salaries for them.
Well, Lisa, I heard all the stuff about radiologists and dermatologists. Everyone would be out of business, but that's not the case, is it?
But what we have in our program after the AI picks up the lesions, it always needs human interactions to go through it. So even with the best methods, still it picks up things that are, human eye never picks up as a location of a disease area. And just some news in the past, there were AI systems that actually generated disease while they were processing the images. So those are scary things that we have to consider when. So if you don't have access to the original data, is just regenerated by AI, it may kind of change the visible or invisible things. So those are all cautionary things that needs human interaction still at this level.
So Lisa, would you say that the AI has transformed the radiology? Because from all I read, that it's quite different now. It's used routinely, I guess, for pre-processing of images or flagging areas.
Yeah, I think one area that is pretty helpful now is use of AI in motion correction. Patients move during, especially the head scans.
Oh yeah.
So, and we get patients who have like even, let's say they have tremors. Is that right? So you want to diagnose the tremors, but the head is constantly moving, the body is moving. So yes, you can kind of somehow put the patient in a way that they stay still, but still it is not helpful. So AI can be helpful, and I think some scanner companies are now using that technology to reduce the radiation exposure. So you can reduce the amount of injection or reduce the amount of radiation, and with AI technology you can. So those are the things that are already been implemented. So I don't think a lot of user interactions are necessary at this point, although sometimes you may see some artifacts generated and then you have to kind of revert what the AI did, or just bring the patient back to rescan them. So yeah, there are different types, but I think as we move forward, we have more technology. Now, one thing I wanted to bring up for evaluation of system is affordability. When we look at it, the global approach to AI for us in North America or Europe, other places, it may not be an issue, but for some places, the digital gap and affordability of the system is a factor for user adaptation of the software. Thanks so much. It was so excellent. I enjoyed the talk, and I'm looking forward for next week talk.
Yeah, we'd love to do some work there to get down to where you are and observe the people using the systems and the real setting. Yeah, great opportunity.
Yeah. Thank you, Andre. Thank you for a great talk. Thank you, Elizabeth.
Yeah.
Thank you so much.
Yeah, great. So what I'll put in the slides, and the recording equipment with the software. I put my email in the chat box. Oh no, did I go to everyone? Oh, okay, yeah, just Borycki almost, everyone, okay. I'll put that in there. Easiest way to get my slides. And then that will have the instructions. Some of you already know how to do screen recording. And Simon there, he knows how to do it on the mobile as well. But anyways, just email me and I can send you that information. Try it out and you'll see how that data becomes the input data into a whole lot of studies that can get quite advanced. Just having that little digital video of the screen and the verbal. Yeah. Okay, thanks. And Lois, do we have a questionnaire? I think a lot of people are gone by now, but questionnaire.